So welcome everybody to Chapter 5, the IS-LM model. What does IS and LM stand for? Like IS is the abbreviation for investment and saving. So we are looking at the goods market equilibrium condition because one goods market equilibrium condition for the closed economy says that investment has to be equal to public savings. And the L and the M, this is an abbreviation for money supply and liquidity demand, like the equilibrium condition for the money market. So now in Chapter 5, we would like to combine the insights we gained from Chapter 3 and the insights we got from Chapter 4. We are combining these two approaches, the goods market and the money market, and therefore it will be possible to determine two endogenous variables at the very same point in time. So we are able to determine the GDP level and the interest rate level simultaneously. It's very important that you have digested already the material from Chapter 3 and Chapter 4, because now it's really a combination of these chapters. It's a very long chapter, so that I'll split this lecture in several videos. Let's get started with the learning objectives. Like after you have worked through this chapter, you should know which parameters influence the slope of the IS curve and the slope of the LM curve. And you should also know what kind of changes lead to a shift of the IS or the LM curve. You should be able to determine in which direction the curves shift horizontally and vertically in case that one important variable changes. You should be able to derive the income and the interest rate effects of a monetary or fiscal policy, and you should know the uncertainties in the adjustment process. You should also be able to describe the comparative static effects in a verbal, graphical, and formal way. So there are always three different possibilities to analyze macroeconomic shocks, either verbally when it comes to the dynamic adjustment process, or graphically by shifting one curve up or down or left or right, and then in a formal way by computing multipliers. And here it is the case that we have two equations and two unknown variables. Therefore, we will use Cramer's rule to determine the income and the interest rate levels in equilibrium as well as the multipliers. As you can see, it's a very long list of learning objectives. It's also the case that we have like about 70 slides this week. So this Chapter 5 will be very intense. So let's get started by looking at the goods market and the IS equation. You are familiar already with the first equation, the consumption function. Consumption depends on the autonomous component of consumption, C0, plus the marginal propensity to spend, C1. And then we have in brackets disposable income, like the gross income Y minus taxes. So this is completely in line with Chapter 3. Then we have the investment function, and here it is the case that investment function is adjusted. Investment depends on one autonomous component, B0. Then investment depends positively on GDP. So in case that GDP increases, it will be the case that investment increases. There is a positive sign in front of this parameter B1. And then investment also depends negatively on the interest rate. In case that the interest rate increases, it will be the case that investment decreases. And this is a new element. This is especially new here in Chapter 5. Because in Chapter 5, we are able to combine the knowledge we gained from Chapter 4, the money and the financial markets, where we determine the interest rate. So it was the case that in Chapter 3, we have not determined the interest rate, and therefore we had to assume that investment was exogenous. And now it's possible to adjust the investment function because We know how the interest rate is determined in the financial markets, and hence we can adjust the investment function here. Government spending is still exogenous. Aggregate demand depends on this three component: consumption, investment, and government spending. So we are still looking at a closed economy. Exports and imports do not play a role. Then the equilibrium condition for the goods market is once more that goods supply, Y, is equal to goods demand, Z. Let's have a look at the new goods market equilibrium condition and solve for the GDP variable. So in equation 1, we have on the left-hand side goods supply, and on the right-hand side consumption, investment, and government spending. It is a case that now GDP pops up 3 times in this equation. Goods supply on the left-hand side, then in the consumption function, and in the investment function. So we want to solve this relationship for Y. So we have to put plus C1Y on the other hand side of the equation. It pops up with a negative sign. And also this plus B1Y on the other hand side of the equation pops up with a negative sign in equation 2. Furthermore, on the right hand side, we have like minus C1T, minus C1T. The minus sign stems from the term in brackets. Then we can write Y out of brackets. We get 1 minus C, 1 minus B1 in brackets times Y. And in the next step, we divide by this term in brackets, and we have isolated Y on the left-hand side of this equation. Now we can once more check how large is the equilibrium level of income, and we are using our numerical example. Like C1 is equal to 0.75. This was also the case in chapter 3. B1 is a new parameter. It is equal to 0.05. B2 is assumed to be 20. Also a new parameter here. C0, autonomous component of consumption, is 400. B0, autonomous component of investment, is equal to 150. And taxes as well as government spending is equal to 200 units. Now we can insert all the information we have, and let's additionally assume in the beginning that the interest rate is equal to 10. When the interest rate is equal to 10, we can insert here the 10 for the interest rate, and then we get for the equilibrium income level that at an interest rate level of 10, the GDP level is equal to 2,000. This is computed in the following way, like we are inserting all the information we have also here in this fraction in front of the square brackets. The fraction in front of the square brackets is 1 over 0.2. So 1 minus 0.75 minus 0.05 is equal to 0.2. And then here the term in the square brackets, so that the equilibrium level is equal to 2,000. When the interest rate increases to the level of 20, of course, it will be the case that the investment function is affected. Less investment is going on, and therefore we can see here that the equilibrium level of GDP decreases in case that the interest rate increases. In the last step, we are reducing the interest rate to the level of 5, so more investment is going on, and therefore the GDP level will be higher compared to the other scenarios. Why is it the case that we are looking at different combinations of the interest rate and the GDP level, where this equilibrium condition is fulfilled? The reason why we are looking at these different scenarios is that we would like to come up with an IS curve. And in this IS curve, we have different combinations of the interest rate and the income level where the goods market equilibrium condition is fulfilled. Like first of all, we looked at this black scenario where the interest rate is equal to 10 and the equilibrium income level will be equal to 2000. Then we had a look at the green scenario where the interest rate was equal to 20 and the equilibrium income level was equal to 1000. And we also look at the last scenario where the interest rate was equal to 5 and the equilibrium level of GDP was equal to 2500. So these are the 3 different scenarios where the goods market is in an equilibrium. And when we combine these 3 dots, then we get our first IS curve. Now I will go back to the other slides. So you are informed already why we are looking at these different scenarios. On slide number 6, we were using one numerical example to find these different combinations, but we can also use like a graphical approach because we worked already with this diagram here where we have the goods market equilibrium condition, the blue line, Y is equal to Z, supply is equal to demand, and we have one demand relationship in case that here the interest rate is equal to 10. So the pink curve symbolizes the demand relationship in case that the interest rate is equal to 10. What is the equilibrium income level? We have to look for the intersection, and here the equilibrium income level is equal to 2000. What happens if the interest rate increases to the level of 20? Then this will affect the ZZ relationship. The demand curve shifts downwards because demand is lower. Goods demand is lower because the demand for investment goods is lower. And hence it is the case that here we get a new intersection in this green point. The GDP level takes the value of 1000. And then the red scenario, the interest rate is at the level of 5%. And the equilibrium level of income is at the level of 2500. And now it is the case that you are already familiar with this 3 different dots, like the black scenario, interest rate is equal to 10, green scenario, interest rate is higher, and red scenario, interest rate is lower. And now I would like to take these 3 different points and insert these 3 different points in this diagram where we have the interest rate on the vertical axis and the income level on the horizontal axis. So now it is clear why this is the black, red, and green scenario. When we combine these 3 dots, we have inserted the first IS curve in this diagram. It is very important that we are working in an interest rate income diagram because of the fact that these macroeconomic variables will be our endogenous variables. And in case that something changes, something will change in this graph, and we can directly infer from this graph how the 2 endogenous variables react. What about the slope of this curve? The slope of this curve is equal to minus 0.01. You can get that when you go like 1000 steps to the right, the curve goes 10 steps downwards. So the relationship is di is equal to minus 10. The change in the interest rate is equal to minus 10. And the change in income is equal to 1000, like from 1000 to 2000 here. So dy is equal to 1000, and this ratio gives us the slope of the IS curve. I don't want to go only 1 step to the right and minus 0.01 step downwards because you can't see it in the graph. And since the relationship is linear, we can augment it and go 1000 steps to the right and 10 steps down in order to derive the slope of the IS curve. In case that you can't remember anymore whether it is di dy or dy di when it comes to the slope of the curve, the following graph will help. Here we have one graph where the variable top is displayed on the top of the graph and the variable bottom is displayed on the bottom of this graph. And when it comes to the slope of a curve, it's always d top divided by d bottom. So d top, the variable which is on the vertical axis, goes to the top, and the variable which is displayed on the horizontal axis goes to the bottom, to the denominator. So the slope of the IS curve is given by, here we have the interest rate, there we have the GDP level, so it's di dy when it comes to the slope of the IS curve. So this is what we want to derive now in a formal way. Until now we worked in one numerical example, and we would like to determine those parameters which determine the slope of the IS curve. We proceed in the following way, that we start with equation number 8, where we have isolated y on the left-hand side of the equation. In equation 9, we take the total differential. Here, once more, it's very important to know which letter represents a parameter. We assume that the parameters are constant, they do not change. Therefore, we don't have to differentiate with respect to a parameter. We only differentiate with respect to the variables. Then we have to think about what we are interested in. We are interested in this relationship di dy because we want to compute the slope of the curve. Therefore, it is the case that we have to put this fraction on the other hand side of the equation. And we have to put this dy on the other hand side of the equation. So it will be the case that here numerator and denominator will flip around, and the slope of the IS curve is given by di dy is equal to, like a minus, 1 minus c1 minus b1 divided by b2. 1 minus c1 minus b1 will be positive, so the numerator of this fraction will be positive because we are assuming that the sum of c1 plus b1 is smaller than 1. In our numerical example, the sum of c1 and b1 was equal to 0.8, so that this condition was met. So the numerator is positive, the denominator is positive, but we have a negative sign in front of this fraction. So the whole expression is negative, and therefore the IS curve has a negative slope. How large is the slope in this numerical example? Let's plug in the values for the parameters we have, and we once more get the relationship that the slope of the IS curve is a negative 0.01. So previously we derived this relationship by looking at our numerical example. In this diagram, the numerical example is displayed, and on slide number 12, it is the case that we are deriving the slope of the IS curve in a formal way. In the next part, we talk about shifts of the IS curve. In case that one variable changes, which is included in the equilibrium condition of the IS relationship, but not displayed on the two axes, the IS curve will shift. So here we are looking at one example where the autonomous component of consumption increases from 400 to 600. The interest rate level is kept constant. The interest rate level is equal to 10%. Initially, the pink ZZ curve is valid, and when the autonomous component of consumption increases, the ZZ curve shifts upwards, and we get a new equilibrium level with respect to GDP. The new equilibrium level is at the level of 3000. Therefore, we can conclude that the black dot here will shift like 1000 units to the right, from the level 2000 to the level 3000. We get that from this previous graph. Like when the autonomous component increases by 200 units, the Z-curve shifts upwards, and the new equilibrium condition is the red one, so that the GDP level increases by 1000 units from 2000 to 3000. The dot here is still black because of the fact that we are still in the black scenario where the interest rate is equal to 10. So this black dot here shifts to the right by 1000 units. So we can say that the IS curve shifts horizontally to the right by 1000 units. Nevertheless, it's also the case that the IS curve shifts upwards. We can also look at the vertical shift, and the IS curve shifts upwards by 10 units. Like this black dot here shifts upwards by 10 units. So the next few slides will be very, very, very important. You are to some extent already familiar with this kind of topic, that we want to derive how much does the IS curve shift to the right or to the left, and how much does the IS curve shifts upwards or downwards, like we want to determine the vertical and the horizontal shift of the IS curve. These slides are very, very important. It will pop up several times in this lecture, but also in each and every lecture in economics or finance. This is a very important topic. So please take the next slides very serious. Let's talk about the horizontal shift of the IS curve, in case that the autonomous component of consumption increases by 200 units. It is the case that we have to think about what changes here, what are we interested in. We know that the shock is the autonomous component increased by 200 units, and we want to find out how much does income increase here. How much does the IS curve shift to the right? When we compare the interest rate level in this black dot and the interest rate level in that black dot, it's always equal to 10%. Therefore, it is the case that the change in the interest rate is equal to 0. The interest rate, when we compare these two black dots, does not change. Therefore, after we have taken this differential here, we have to think about what kind of changes are equal to 0 because of the fact that these variables are constant. So we are interested in the horizontal shift. We are interested in this variable. We cannot set this variable to 0. Then it is the case that here the shock occurred, like the autonomous component of consumption is up by 200 units. Taxes do not change, so the change is equal to 0. Autonomous component of investment does not change. This change is equal to 0. Government spending does not change. Change in government spending is equal to 0. And here, this is the important part. When we compare these two black dots, interest does not change, and therefore the change in the interest rate is equal to 0. So this is 0, this is 0, that is 0, and also this part is equal to 0. So we are only left by putting DC0 on the other hand side of the equation, and then we can compute how much has Y to change in case that DC0 changes by like 1 unit. The whole expression is positive because also the denominator is positive, and this implies that when the autonomous component of consumption increases, y has to increase so that the equal sign holds, and therefore the IS curve has to shift to the right. By how much does the IS curve shift to the right in case that C0 changes by 1 unit? When C0 changes by 1 unit, then the IS curve will shift by 5 units. In our numerical example, it is the case that the autonomous component of consumption does not change by 1 unit, but by 200 units. So we have to multiply through by 200. And hence we get here that the IS curve shifts to the right by 1000 units. In the next step, I would like to talk about the vertical shift of the IS curve in case that the autonomous component of consumption increases by 200 units. Like the vertical shift, we have to ask ourselves, what about the GDP level in case that I compare this black dot here and this dot? GDP level is always equal to 2000, so the GDP level does not change when we talk about the vertical shift. We are interested by how much does the IS curve shifts upwards or like downwards. We once more start with a total differential. Now it is the case that dy is equal to 0 because of the fact that the GDP level is always at the level of 2000. The change in income is equal to 0. Therefore, we can set this relationship equal to 0. We are interested in the relationship dc0 and dy. So only this term matters. The other terms are equal to 0 because these variables are constant. We have to look for the relationship di dc0. So in the first step, we can put this minus b2 over 1 minus c1 minus b1 di on the other hand side of the equation. We get to equation 17. Now we can divide by dc0, put dc0 on the other hand side of the equation. And when we multiply through by the reciprocal value of b2 over 1 minus c1 minus b1, we are multiplying through by the reciprocal value, then this term will cancel out against that term, and we are left with the relationship di over dc0 is equal to 1 over b2, which is also positive. So there is a positive relationship between dc0 and di. So in case that the autonomous component of consumption increases, then also the interest rate has to increase so that the equal sign holds, and hence the IS curve has to shift upwards. By how much? In case that C0 only changes by 1 unit, then the IS curve has to shift upwards by 0.05 units. But here in our numerical example, we have to multiply through by 200 because dc0 changes by 200 units, and hence we find here the answer that the IS curve has to shift 10 units upwards in case that the autonomous component of consumption increases by 200 units. The last slide is also very important because it indicates when does this IS curve shift and in which direction does the IS curve shift. First of all, we have here the general definition, like an equilibrium curve shifts if one variable changes, which is contained in the equilibrium condition, but is not indicated on one of the two axes. So in our model, it will be the case that the IS curve shifts to the right in case that the variable changes, which has a positive impact on the demand for goods. This is the case when the autonomous component of consumption increases, the autonomous component of investment increases, or in case that government increases government spending. Furthermore, also the IS curve will shift to the right in case that taxes decrease, because a decrease in taxes increases disposable income, and this has a positive impact on the demand for goods. This is the end of the first part. Please take some minutes, please take some time to look what we did in this part. It is very, very important that you understand the basics. When you don't understand what's going on in this part, you will never be able to follow what's going on later on in the ISLM model. Like right now, we have just focused on the IS relationship and we derived the IS curve and the characteristics of the IS curve. In the next video, we will focus on the LM relationship. So the same procedure as in this part of the lecture. And then in a third step, when we have derived the ISLM model, then we want to work with the ISLM model. So it's very, very important that you get the basics. Thank you very much. Have a nice day. See you later. Bye-bye.